In today's video, I'm going to discuss about the calculations for cylindrical axis and the power during JCC refinement. Let's start with the axis. Let's take an example of -2 with -1 at 90 degree. So this is the power we got from the subjective refraction. Now we are going to refine the axis 90. Let's see. So 90 is here, 180 is here. So the rule is simple. We are going to move towards the minus cylinder axis. So let's imagine in position 1, the red line minus cylinder aligns here. When you flip, it will go to the other side. So position 2 is here. So let us imagine your patient preferring position 1. That means you are going to move towards this side. Let's say you are moving 10 degree from here. So you will keep your axis at 80. At 80, you need to refine it again. Let's imagine in the next 2 to 3 flips, your patient saying both are same. That means your refined axis is gonna be 80. You need to write your prescription as -2 with -1 axis 80, which is our refined axis. Let's imagine the another situation where your patient preferring position 2. That means you are going to move towards this side. Let's say you are moving 10 degree from here and you are keeping the axis at 100. You are doing the second flip. In the second flip, let's say your patient preferring position 1. That means the axis is in between 90 and 100. So what you are going to do, just move 5 degree back from here. Keep at 95 and refine it again. If your patient saying both are equal, then your final refined axis is going to be 95. We need to write like -2 with -1 at 95. This is our final refined axis. Here I want to give you a simple tip. During your first flip, if your patient preference is less strong, rotate your axis only by 5 degree steps. If your patient preference is more strong, you can rotate it by 10 degree steps. But what I would say is, if you are a beginner or just started to learn about JCC, you can keep your axis rotation by 5 degree steps to avoid major mistakes. So that's all about the axis calculation. Let's move on to the power refinement calculation. When you are refining power, you always have to remember one important thing, which is your spherical equivalent. So maintaining the spherical equivalent is very important when you are refining the power. So let's take an example of -2 diopter sphere with -2 diopter cylinder at 90 axis. So according to the procedure, let's say we have already refined the axis. So we are going to refine this power, which is -2 here. So let's imagine in position 1 where the red line, the minus cylinder axis, is aligns with your cylinder axis in the trial frame. In position 2, black or the white line, which is our plus cylinder axis, aligns to the cylinder axis in the trial frame. So let us imagine your patient preferring position 1. Okay, before calculating, I just want to tell you, I'm going to do all the calculation with the most common plus or minus 0.25 diopter JCC. So we are going to do with 0.25 diopter JCC. Let's say your patient preferring position 1. That means we are going to add minus 0.25 to the existing cylinder. So let's calculate. Our existing cylinder is -2 diopter. I'm going to add minus 0.25. So the total is going to be -2.25 diopter, which is my new cylinder, which is the refined cylinder. So my prescription is going to be -2 diopter sphere with -2.25 cylinder at 90. This is my refined prescription. So this is going to be my final prescription after reaching the end point. Let us imagine one more situation where your patient preferring position 2. That means I need to add plus cylinder, plus 0.2 the existing cylinder. My existing cylinder is -2. So I'm going to add plus 0.25, which is going to be -1.75. So here, let's say you're doing the second flip. In the second flip, your patient preferring position 2 again. That means you're going to add more plus. Let's add 0.25. So this is going to be minus 1.5 diopter. Here, I need to remember about the spherical equivalent. Because throughout the procedure, I have changed around plus 0.50 diopter from the initial cylinder. So what I need to do here is, I need to add minus 0. diopter to the existing sphere. So the existing sphere is minus 2. Let's add minus 2 diopter. So its total is going to be minus 2.25 diopter. This is my new sphere. So my final prescription is going to be minus 2.25 diopter sphere with minus 1.5 diopter cylinder at 90. So this is going to be my final refined power. And here, if you want to confirm is the spherical equivalent is maintained throughout the prescription or not, you can just calculate your spherical equivalent for before and after refinement prescription. Let's calculate for this. The formula we know, sphere plus half of the cylinder. Half of the cylinder. So the sphere is minus 2 diopter plus cylinder, half of the cylinder is minus 1, which is going to be minus 3 diopter. This is the spherical equivalent for this prescription. Let's calculate for after refinement prescription. Spherical equivalent equal to minus 2.25 sphere plus half of the cylinder is minus 0.75 and its total is minus 3. So it's the same. So it's maintained throughout the prescription. Now you may think why we didn't change anything when we are adding 0.25 diopter in the cylinder. To clarify this, let's calculate the spherical equivalent for this also. So it's minus 2 plus half of the cylinder is 1.12 and the total is going to be minus 3.12. This 0.12, which is 0.12, won't make any big difference. But in a real refraction, we only have plus or minus 0.25 diopter steps to make any significant differences. So that means the 0.12 diopter won't make any big difference. So this means the spherical equivalent is maintained in this prescription. So when you are changing only 0.25 diopter in your cylindrical, you don't need to worry about altering your spherical. So that will stay the same. So this is all about the calculations. These are very simple if you practice regularly and try to do calculations with your complicated prescription. This will become more easy than you think. Click, clap,